to the power of declarative design. I'm going to start with a bit about myself. I belong to the pets that you see here, and in the bottom right, you can see my beautiful wife, Meredith. She's hugging our two danger floofs. I live in Greensboro, North Carolina. I enjoy reading books, playing video games, studying the Japanese language, and above all else, spending time with my family. As for what I do, I'm the author of Ash Framework, a resource-oriented declarative design application framework for Elixir. So what do we mean by application framework? Many folks are used to building their applications with web frameworks designed to help you build web apps. And in Ash, we take a different approach. It's a framework for building your application layer and deriving capabilities from that layer. It has extensions that extend into the web layer, for example, Ash JSON API and Ash GraphQL for building APIs. And those using Ash will often use Phoenix, which we're all familiar with, if they're looking to do things like build a front end or add custom functionality. You can do all sorts of things. They play together very nicely. I'd like to thank my employer for funding my work on Ash and my attendance at conferences. Alembic is an international software agency with deep expertise in web development, distributed systems, and wrangling complex software requirements. We combine great people with leading tech to help businesses build ambitious software applications simply, efficiently, and sustainably. So if you're looking for help with anything, come find me after this. We can see what we can do for you. So I'm going to start by defining some terms. And declarative, the way that I use it, is in contrast to imperative. So in imperative paradigms, we prefer code, and in declarative paradigms, we prefer data. In imperative paradigms, we prefer to provide instructions, and in declarative paradigms, we prefer to provide the end result. So you could imagine saying to your child, pick up your toys, put your laundry in the hamper, make the bed, or you could say, your room better be clean when I get home or there will be hell to pay. A very important aspect of declarative design is that it only works if your kid knows how to clean their room. Like you can't say clean your room and then you've never taught them that before, right? So it requires smart tools. In order to use something declaratively, something has to know how to do what you're telling it to do. Another important bit about imperative and declarative is that it's a relative thing, right? Typically relative to how much you used to have to tell the computer to do before somebody made some new thing that is more declarative. So here you see an example of iterating over a list in JavaScript. This is more imperative than this one. This one is more declarative. We say list.forEach, and we don't explain how to iterate over the list. It knows, the implementation is encapsulated. And so in that way, imperative versus declarative is relative. In the future, however, declarative and imperative might be compared by, they might say imperative is spending 6 months building an app, and declarative is asking ChatGPT 42 to please make me a bunch of money. So there's a lot of methodologies that come into play when you're doing declarative design, but we're going to focus on two. They're really powerful, and they can transform the way that we build software every day. Everything we do in Ash is backed by these principles of declarative design, but the point of this talk is actually how you can apply these unrelated to Ash. So the first thing that the number one priority with declarative design is to prefer data over code. And the second one is derive over handwrite. And I would suggest that the first one sort of powers the second one. So let's take a look at some code. This is an input validator. And the way that it's implemented here is I've given you an example of one of these functions, validate name. And it takes the name out of the input object, checks some properties of it, and then maybe would return an error or say, yeah, that's fine. And then we store the list of rules that we have. And you can see there's actually some of this is modeled as data, right? Those functions are in a list, so we have some data. But we can actually, favor data more specifically, right? So we could lift up what field this validation validates, and we can lift up the error message that it could produce if that validation fails. And in the process of doing that, we open up new angles of attack, right? So this is easy to read. I would suggest that it is easier to read than this one. It's easy to talk about, right? So when we're talking about what's the field that it's validating, I'm not scanning code. It's the first thing in the tuple in that list. It's very easy to talk about. It's easy to change, right? If a field name changes, I don't have to go find all potential references to the field name. Again, I'm changing the first thing in the tuple in that list. And it also has flexible usage. And this is that angle of attack bit that I was talking about. So for example, I could add a function that says validate one field. right? Let's say I just want to check, is this value for name a valid name? And because I had lifted the field that was being validated as data, it wasn't just somewhere inside of a function, I was able to say, okay, we'll get all the validations for that field and just run those. I could also do things like, well, what are all of the possible error messages that could come from the validator? This could be useful for things like, either reporting or translations or displaying in the UI, like here's the requirements that you have. And you can see that like in this, those two things I showed you would not be possible. You would have to refactor this code to validate one field or to write all error messages. So let's talk about derive over handwrite. This is an example of, in your UI, you're going to show like a field tip underneath the age field that like, hey, you've got to, here's what the rules are. Almost like a password validation or something like that. And you could do it like this instead. So we could ask the input validator, what are the requirements for age? And we could list those dynamically. And so in this way, it'll never be wrong. If the age limit is changed to 21, it's not possible that the UI does not reflect that. I want to point out that derive over handwrite requires taste to do correctly, because there's another version of this that looks like this, where why bother listing each field explicitly in my UI? If the validator knows what all the fields are, why not loop through each field in the validator, display an input for it, and then show the field tips for that validator? And I would suggest that the main thing here is that when you are deriving things from some source of truth, it's very swingy. It's easy to make a change you didn't intend in some other place. And typically, the order that fields appear in a form is like an explicit concern of the UI. You wouldn't, as a developer, go think if I change the order of the list in my input validator, that's going to affect the user experience down the line. So tasteful derivation is important. So how do we put this into action? I'm going to take you through some code that's going to grow with some new requirements, and I'm going to show you kind of where it can get to and then how we could actually refactor it to leverage these principles. So we've got some business logic. We can create a person, we can create an organization, and we can create a post, right? And we ship this. Client's happy, product's happy, they're creating stuff, it's all great. Everything's going great, but we get a call from our customer and say, hey, every once in a while I get an error when I create a post. And we're like, well, okay, we should probably introduce some kind of, or my posts are very slow. So we should introduce some kind of like timing or reporting type thing. And look, there are only 3 functions, so we can just make a time function and have that like, send out a log message or something like that. It doesn't really matter the implementation of this. But this is simple, right? Not bad code. So a few days later, it's explained like, hey, we've got some interns starting. And we want the interns to be able to create a post, but we don't want them to be able to create people and organizations. So we say, well, here's a really quick fix for that one. Now our functions and our business logic take a user. And in the places where an intern's not allowed to do it, we can return an error saying, hey, you're not allowed to do this. Again, this isn't really bad code, but the important thing to realize is that for most of our applications, they are not just 3 functions. Like the surface area for our business is not 3 functions, it's 100 or 400 context functions that power whatever it is that you're doing. So we have to look at how these expand into, how do these sort of scale from a concept perspective. So we're going to keep going. We need to create an audit log because we realize somebody's been creating posts that have, swear words in them, and we need to know who's been doing that, right? So now we create an audit log, and we make sure that if you create a person, or if you create an organization, or if you created a post, that, hey, we're inserting into an audit log somewhere, super useful stuff. We also need to make sure this code's documented, right? It's really important. If we're working with it in our editor, we want to get some autocomplete. If we're exporting docs, or even just if I'm looking at this function, I want to know what it does. So again, this is not bad code. These functions are simple. And one of the hard things about expressing problems, like when we talk about like spaghetti code, is there's no projector big enough to show you spaghetti code. Like actual spaghetti code requires scale. It requires tons of functions. It requires tons of switching of different requirements all over the place, right? But this is, in a micro sense, a scale of spaghetti code. And what I mean by this is there's opportunity for sort of hidden divergence, right? So create post takes a user, but it doesn't forbid interns. And in order to do that, in order to understand that that's the case, you have to read the code. There's the only way to do it. There's no way to communicate that. We're not encoding that in data in any way. And so in order to understand what this domain does, what this some business logic module does, you have to read it from top to bottom. That's the only way to do it. So let's go ahead and just see what it looks like if we apply our principles. Again, if this was actually all of your code, I would not suggest refactoring it. If you actually just had 3 functions that looked like this, don't touch it. Let's start with data over code. So we're going to extract data from this little snippet of code. This is a concrete implementation of creating a person. So I'm going to ask the audience to help with this. So there's a lot of things in this that could meet the criteria, but I'm looking for 4 specific things of data that is contained in this code. And I'm going to get you started. The first one is the type of thing that we're creating. That's a piece of data. It's not necessarily code. So does anybody out here have an idea of what another piece of data is in this function? The error, actually, yes, not the one I was looking for, but yes, that's a good one. The audit log, so the audit log is just using the same thing, the type of thing being created, so that we're kind of considering those the same. But related to the error, what a piece of data might be, what could, go ahead? Yeah, exactly. So there's some data which is, I would suggest that the way to phrase that is if interns are allowed is data, right? So that's input data, like are they an intern? But data about the function itself is are interns allowed to do this thing? Any other pieces of data that you can spot in here? Do we need to audit it as one? Right now, all of these are being audited, and so I didn't consider that for this slide. Like I said, there's a lot of things that you could potentially classify as data. I'll give you one. Oh, go ahead. The error type. Yeah, that was, I think that's classifies as data, but not what I'm looking for. Yes, the schema. So what is being inserted as a result of this operation? That would classify as data. In this case, it's a constant. All of them are using the same repo. So we've got one more, and it's the biggest thing on the slide. Nope. Biggest, was that docs? Yeah, docs. That's data, right? So we've identified, I would suggest, the 4 sort of most important pieces of data in this. And we're going to ignore the docs for now. We'll circle back. We'll have a retrospective on it. Let's make it data, right? So this is the concepts from this code that we were looking at for each one of those functions. And I have to go back through all of these, sorry. But it's encoded as data. This is useful. This is even just doing this, even just seeing this makes the other code easier to understand. And we pair these things together, or like let's take a look at like the generic implementation, right? So now this is something that can take that data and actually do the work, right? So here we get the configuration, like what is the operation that's happening, what are the rules. I skipped one here, which is we put that type, we figure out like what's the name of this operation, and we check, hey, does this thing allow interns? And then if not, then we're going to say, hey, you can't do this. If not, and the user is an intern. And another thing here is we insert into the schema that we got from the data. And here we've paired 2 really useful separate things, right? We have the declaration and the implementation, or perhaps you might say the what and the how. You've also maybe heard this as like the state in an engine, or the rules in an engine, or something like that. So we're going to look at next applying the derive over hand write principle. Show of hands, how many people in this room have looked at some function documentation and then looked at the function itself and saw that they didn't match? You should all have your hands raised. There's no way that hasn't happened to everybody here. So we've all been burned by stale documentation. I think it's a pretty universal experience in programming. I'm sure that you've read a function that I have written and documented and that it was wrong. So we can solve that problem. So here we're going to create a separate module just for reasons like you can't call private functions that are in your module while building docs, but don't worry about that. And we're going to take the config, we're going to take the type, and we're going to actually dynamically build the documentation. Obviously, this is harder to read than handwritten documentation, but the general idea with these things is this isn't what you read, right? So here we can say, add the documentation to this function. And now I get autocomplete in my editor that cannot be wrong. Like if we change the schema, or if we change the name of the thing being created, and we can lift these, we can apply this even further. We can show like here's the attributes that it accepts, here's all this sort of stuff. And it's evergreen documentation. I think evergreen means what I think it means. It is not possible to be wrong. And you can use mixed hex docs for this. This is especially powerful in libraries, and you'd may be surprised how many libraries apply exactly this, right? There's all sorts of options validators or schema validators that come with a function like docs that return you a doc string, right? So very common pattern. So we're going to switch here, and I'm just going to show a little bit about how we take these principles and extend them, essentially to extremes in Ash. So in Ash, we have a concept of a resource. This is a simple resource. Again, I'm not teaching you how to use Ash, but here you see we got a resource. It lives in a Postgres table. It's got some attributes. It's got some relationships, and all that this is a data structure, right? There are macros here that sort of power this, but at the end of the day, it's a data structure. And that's proven by the way that we actually work with these things. The resource doesn't do anything. It doesn't start a process. It doesn't define any functions. Well, a couple of them, but don't worry about that. It's just an introspectable data structure. So we can say, well, what are the attributes of a user? Or we can say, what are the relationships of a user? Or what database table does it live in, right? So we leverage this concept of introspecting a data structure to do a lot of very cool things. So let's talk about how this applies to our data, right? So in Ash, when we're working, we make some changes to our resources, like we add a new thing called accounts, and then we run mixash.codegen. And what that does is that actually looks it introspects all of our resources. It takes snapshots, and it compares the old snapshots we took with the new snapshots to generate migrations for you. And these migrations are actually pretty smart, right? Like we added a database level UUID default value. We lower could it be null or could it not be null, all that sort of thing. And it actually does quite a bit beyond this, but we have to stick with the basics here. And we do this on a loop. So we run mixash.migrate to apply it to our local database, and then we keep working. We make some changes, code gen, migrate. It's quite nice. We also apply this concept of data first to our computations, what we call calculations, which is that this expression is data, which means that we can use it in the database, or we can use it in memory. You can say, compute the full name, and you don't have to make a round trip to the database, but you can if you want. It's a very useful property of Ash expressions. So when applying declarative design to actions, to the verbs in our system, this is actually typically where things might fall apart, or where people would not be able to find a good way to apply these principles. But we do, and the ability to do that is one of the main drivers for everything that Ash actually offers. So for example, we might have a register action, and we can do some simple things to expand it, like there's some built-in options that do basic stuff, like accept email means they can create this and they can give me an email when they do, and we'll save that email. But you can also do things like this. You can add arguments, right? They might be you might see them as something like a virtual field in Ecto, but these arguments are transient inputs for this action, and then we can provide changes. So a change is a plug. It's a plug that takes a change set and returns a change set. That's all that it is. But it's a way for you to just drop in any arbitrary custom behavior to your actions. And in here, you can see it's going to take that password. It'll hash it. I mean, I'm not showing you the implementation, but it'll hash it, and then it'll write it to the hashed password field, for example. And so this is all data. Like, this doesn't define a register function. There's a struct available on the resource called action, and it has an accept key in that struct, it has an arguments key in that struct, and it has a changes list, right? So we can introspect all of this information later. And we use this to do things like allow you to define an entire GraphQL API with 5 lines of code. So given that register action, this isn't like a trimmed down example of the code that lets you make a GraphQL API. That's actually all of it. So that's all. You set it up and you have like an absent schema somewhere off to the side. But from your development perspective, this is all that you have to write. This is the same thing for a JSON API, like a JSON API spec compliant API. That's all the code that you need to do. And the reason for that is, well, we know that it's based off of an action. We know what the rules of that well, not the rules, but we know what the interface to that action is. We know what the types are. And we can also generate a code interface. So this is like your internal API. Now, we don't do like Rails magic where you like just define named functions based off of any sort of like, I don't really remember what it was like when I was doing that in Rails. I just remember not liking it. We firmly believe that all external interfaces, or all interfaces, internal or external, should be explicitly designed. And so we have you say, make a register function, and this will make a, register 1, 2, and 3 that takes an email. And this is what your GraphQL looks like, right? It's not like a sort of pithy GraphQL endpoint. It is, all of the mutation errors are spec'd, the inputs spec'd. If you're doing read actions, you get a full filter object, sort, pagination, everything is built into the framework, and therefore it is built into the API implementation. And we do the exact same thing. There is no extra configuration required to have a complete open API specification of your API. We know the types of everything. All of our types implement things like what's the open API spec or schema for, what is the JSON schema for this data type coming in, and what is the JSON schema coming out. And that's all the information that we need. And we do the same sort of thing for your code interface. So you define a function, we make the function for you, and the beauty of these functions is that you can't do them wrong. You can't come across a code interface thing that bypasses internal logic of the action, because we wrote the implementation derived from your resource. And we can get insights. So when you don't do anything extra to make this work, as you're designing your Ash application, you can just say generate resource diagrams, and here you are, you have a mermaid diagram. And it's important to understand that this is not a data diagram. This is a domain level diagram. So these are domain operations, right? Lock accounts might do multiple things, open member account might do other things, right? But we're showing what are the things that my domain itself can do. And as you probably can't see from this really big mermaid diagram, we actually also do, Ash has a policy authorizer, and that policy authorizer is like every other thing that we have. It encodes your policies as data, or you encode your policies as data. And that means when your security team says we need to do a security audit of every single thing that can happen in our application, you have one command that will generate a bunch of mermaid diagrams that is the exact authorization flow taken internally, like the decision tree of can a user perform an action against this resource. Super useful, and the beauty of it is because it's data, I can do these things for you, right? Like Ash, the framework, can do these things. You can write extensions that will do these things, that will read this information, and this enables such a significant amount of leverage and a significant amount of speed. So we have a zero config admin UI. It knows what all your resources are, it knows what all of your actions are, it knows what all of the inputs are, and all of their types. So why should you have to hand write this, right? Now, I would not suggest making like your real user experience in this way, right? This is not pretty necessarily, but it is very functional. And to get this with zero effort, right? That's wild. So our application architecture, generally when we're working with Ash, looks like this. We have our application layer that should say domains, not APIs, in quotes there. That's for 2.0. They used to be called APIs, which was a horrible name for what they were. But yeah, we generate a bunch of things. We generate our admin UI, our GraphQL layer, our JSON API layer. We don't write explicit, ecto querying code. We use Ash to query our data, and it writes queries for us. We even have things like ETS, Amnesia, CSV. There's a CubDB data layer. We have, it's still experimental, but a JSON API wrapper where you can declaratively define some other external API and map the things in that API to your resource, and you can filter it and sort it and paginate it as if it was some like local data. So the general process here looks, when we say our tagline is model your domain and derive the rest, right? So you have your DSL module, which is just data, and then we derive a bunch of stuff from it, right? Kind of restating what I already said. And to restate myself again, you could do things like generating internal code APIs, JSON API, GraphQL API, application components, database structure, reusable building blocks. You get a wild amount of reuse because everything's very consistent. The way that you plug new behavior into one thing is a defined thing. We have a bunch of callback or a bunch of behaviors, right? You implement a module with this behavior, and now you can use it in this way. Integration drivers, right? So if you're working, we have people who have written custom extensions, custom data layers. Somebody who attended our training yesterday had written an Ash Sanity data layer, which is, Sanity is a CMS, which is, funnily enough, not the most sane choice to make. But we can also do smart UI components. So on Hex, there's an Ash table, right? Give it a resource and a read action, and it's going to give you a filterable, sortable, paginatable, live component, or maybe function component, I forget, to use that. So when we leverage this concept, you can get so much stuff for free, and other people can build these things because they know how to work with a resource, right? They don't have to know how to work with your resource. They just have to know how to work with a resource. So I've got a little bit of news. I actually have gone a little quickly through this on purpose because last night at midnight, maybe after a few old fashions, I had a conversation with a bunch of people about AI, as we might do at this sort of conversation. And somebody was like, what can you do with AI in Ash? And that got the cycles spinning in my brain. And I'm like, I don't know, let's go find out, right? So I'm going to give you some news, and then you're going to see. I'm going to do a live demo, which is something I told myself I would never do, let alone a live demo of something I developed last night for 2 hours in a hotel room. Yeah, but we got some news first. So we have a package called Igniter. This is something that's not specific to Ash. It's designed for the entire ecosystem to leverage. And what Igniter is designed to do is to drastically improve the user experience for things like installing new packages and for code generation in general, right? So you can do things like mixigniter.install, and that's going to go to hex, figure out what the version of that thing is, and it's going to put it in your mix.xs file. It's going to look if it has an associated installer, and it's going to run that installer and patch a bunch of code into your project, showing you a diff, saying, hey, is this what you wanted to do? And you can say yes. And it's a bunch of fluent tools and composable utilities to actually do this in a way that doesn't suck. Because most of the time, if you see a patching generator right now where it modifies your files, it's built on regex. What we do is we use Sorcerer, if you're familiar, to actually use the AST to do this, and we provide a bunch of functions for working with the AST. And yeah, we use these source-aware patches to do things like installers, but also application-specific commands. Like maybe someday there will be a mix phoenix.add.route that just adds a route to your router file, right? Some things that we're working on now. So Ash Authentication has been a really successful package, but it's kind of on the far end of the spectrum from Phoenix Gen Auth, right? So I don't personally take the approach that my authentication code should be generated in my project. I would like to be able to receive a security update if one is required. And I also think that it can be kind of limiting, right? Because we want to be able to just say, I want Google, I want OAuth of some kind, I want Magic Link. And a library can actually do that for you. We can keep working on features, and then we can give you just a way to opt into it. However, the right answer, as always, is somewhere in the middle. And so now that we have Igniter, we're going to be doing some installers where you can add strategies. For those who have used Ash Authentication, you'll probably understand why this is nice. So it's going to be a lot less implicit, much more explicit, and it's going to add actions to your resources for saying things like register with Google that you can hook into easily. One other bit is mix ashpostgres.gen.resources. This is really useful for just getting started. This is almost done. But what this will do is this will look at your database, and it's going to find all the database tables and create resources for them. And it's going to support options like -- extend. So if you wanted a GraphQL API that called into your database directly, you could just say -- extend GraphQL. And that's, I think, an entire product series A is slapping APIs on databases. And we don't need those. So this is where I was going to end. But instead, I'm going to do a demo. And I legitimately have no idea how this is going to go. So you're all going to have to bear with me. All right. So we have a little app. It's called Twitter. Ours is actually a little app. All right. So we've got 2 users in our Twitter app, right? This is just a little thing that ensures that they exist. Can you not see it? All right. I will fix. It's called Twitter, OK? We're taking it back. OK, so we've got a little file here that ensures there's 2 users that exist when we start up our shell. And it's a really simple app, right? So we've got users that you can create a user, you can read a user. They've got a unique username. You're welcome. So you also have tweets, of course. Tweets are really simple. You can create a tweet. The one thing that we have that we've had an example for here, let me comment this out for now, is you can create a tweet, but you can also say if it's private or not, right? So that's the entirety of this little app. Doesn't do much. But I wanted to put my money where my mouth was when I said we can derive really powerful things just with the definitions of your application, right? So now we have a package. It's called Ash AI. And I can say ashai.chat, and I'm going to say with Zach. All right, so now I'm chatting with my app, right? And I could say something like, what can I do? All right, it says, well, as a user, you can perform several actions related to your Twitter account. That wasn't the cool part. I actually want to do stuff. Can you create a tweet for me that is about how cool AI is? Hey, look, it made a tweet. AI is incredibly cool, from everyday applications to groundbreaking discoveries, right? So this is actually using our application. And the way I can tell it how to do that is because I know what the application does. I can lift the actions to JSON schemas. We already have that tooling for JSON, AshJSON API. It already exists. Why does this take 2 hours? Because this is how this pattern actually plays out at, when you extend it like this. And I can even do things like, can you please write a tweet that contradicts my last tweet? So this is going to run it. I mean, if it does it, we don't really know what it's going to do, right? But what it should do is it should say, well, I need to know what their last tweet was. Look, orders by inserted at limit 2, and now it's going to contradict my last tweet. What's really important about this pattern is when you build on top of an application layer, you're not chatting with your database, you're chatting with your application, is if I go over here and I actually say, well, hey, tell you what, these policies say, hey, anybody can create a tweet, but if you're reading a tweet, you're only allowed to do it if it's not private or if it's a tweet that you made, right? So let's go ahead and enable this, enable these policies. All right, and I will reload this. And I'm going to make a tweet from me, make a private tweet about how cool Jose is. All right, we're inserting a private tweet. Look, there we go. And now let's go ahead and exit this. And I'm going to do this as Jose. And I'm going, yeah, no contradicting that, yes. All right, and so from here I can say, what tweets has Zach Daniel made? So what you'll see is I'm going to get a user with that username. It likes to do that for some reason. And it's going to say, oh, there is no, oh, it's Zach. Right. All right, because reasons. What tweets has Zach made? All right, it's going to find me. And the authorization policies automatically restricted the data access that your robot had to the things it was allowed to see. So you can actually just slap this onto your website and not worry, like, is this going to expose some data that it wasn't supposed to see? And these are the kinds of things that we can build with declarative design. Thank you.